It's obviously not going to be allowed. You're just not going to have it with you. So how do you add these numbers quickly?
9 plus 10.
Yeah, you could do that. I would probably do 9 plus 11, 8 plus 12, 4 plus 16. They all give a total of 20. So that's 60, and then you can start adding the other ones if you want. So then, 4 plus 16 gives 20, 12 plus 8 gives 20, and so on. 9 plus, when you add them all up, you think you get 98, and there's 10 numbers, so it's 98 divided by 10 is 9.8. Okay, question 2 then, a regular polygon with 24 sides. So if you know your formulas, that's n minus 2 times 180 divided by the number of sides will give the angle. So the number of sides 24 minus 2 multiplied by 180. So once again, this is more of a challenge to do this without a calculator than maybe remembering the formula. So that's 22 times 180 divided by 24. So I would, if I was doing this, I would think about, right, I need to simplify this. Well, maybe that's the same as 11 over 12. Then I think about, I know that 6 divides into this, so it goes twice, and 6 divides into this 30 times. Oh, actually 12 would have divided in. So 2 goes into that once, 2 goes into that 15 times, and now I just have 11 times 15 on top, which is 165. So doing that without a calculator, that's a skill. So they tested your numbers, arithmetic skills at the start here. Question 3, substitution in. So we get p is equal to 2 times 5 minus 4 times 2 squared minus 3 times minus 3. So that's 10 plus 16 minus 9. And I should get, plus 9 is 35. If you're wondering what attempt marks you should get and all that, you can just ask me. Otherwise, just give them the marks you think. You're going to tot them up at the end. Question 4 was a interesting one. They give you what root 7 is, an approximation of root 7, and they give you what root 70 is, an approximation. So you're going to have to use those two numbers to find root 700 without a calculator. So what I showed a few of you guys is, this is your Cert's knowledge. I can split that up into root 7 times 100. Why did I pick root 7? Well, because I have an answer here for root 7. I could have picked root 70, but then I would have had to done root 10, which I don't have an answer for. Because I know the square root of 100 is 10, and I know that's 2.65. So 2.65 times 10 is 26.5. So that gives 10, that gives that. And the second one, I'm going to obviously have to use root 70. So that's root 280 gives root 70 times root 4. Root 70 is given above as 8.37, and root 4 is just 2. So if you double that, I think you get 16.74. Okay. The next one was your frequency of a spinner, so probability question, even though you hadn't really done probability. But you've done probability every year up until this year, so you probably figured it out. What's the relative frequency of the spinner? So how often does the spinner land on 2 compared to everything else? So there's possibility of, this is question 5a, it lands on 2 48 times out of a possible 200, so that is your relative frequency.
Did you do it in percentage?
Yes, or equivalent if, so 24% will work, or 12 out of 50, or fully simplified 6 out of 25 works. There is in the mark scheme, if you saw it, there's this OE thing which says or equivalent. So anything that's equivalent to that fraction will be marked correct. You did not have to simplify for full marks. You could have just left it as 48 over 200. Okay, next one, if the spinner is done 1,000 times, what would you how many times would you expect it to land on 2? So that means if 1,000 spins, you have this as your probability. So if that happened 1,000 times instead of at this probability, that would be what you kind of need to create. or something like that. Multiply that by the probability. If you roll the dice or flip the coin 1,000 times, what's the probability of getting heads? You would just multiply 1,000 by a half and you get 500. Same thing here. The quick maths bit on this, maybe 200 fits into 1,000 5 times, which helps. So 5 times 48 is 240, I think. 240 for that one. Question 6, we have to solve an inequality. So 2x plus 6 greater than 5x minus 10. If you solve this, bringing the x's to the same side, so subtract the 5x over here. I think you get minus 3x, and subtract 6 from both sides, you get this. If I don't like my negatives here, negative x, I can make them all positive if I change all signs. So notice the middle one changes direction with that. If I want a positive x, which I do want a positive x. And then I divide by 3. So I get this, no, 5 over 3 as my answer. Is that as much as saying? Yes, that's it. So if you had the sign the wrong way around, you'll get definitely a mark off. The next one. Is it not what?
It's not like
Fully solved, give a mark. Yeah, if they've done something, a step in the right direction, normally it's just a mark. I'm way behind. The sign the wrong way, give 1 mark. Okay. Question 7, what's the opposite transformation? The inverse transformation. So if something's gone this way, what's the opposite or the inverse?
2 negative 5.
Yes, just gone back. So it's got to go back 2 and then down 5. If it's gone left 2 and up 5, it's got to go right 2 and down 5 to go back. Yeah. Yeah, I think that's okay. If she, what'd she write? 2 right, down 5? Yeah, I'll give that. Yeah. Did she say translation? Go on, be harsh. Give 1. 1 out of 2. Be harsh. Oh, it's yours. Okay, sorry. Yeah, so I need the mark scheme in front of you. Usually, with your transformations, you need to say what transformation it is. Yeah, so that's the original. So how do you undo it? You have to also translate. If you use the vector, that's already a translation. So I would probably just don't leave it up to chance and say which one it is. Next one, enlargement, scale factor 2 with a center 2 to 3. So something's gone from 2 to 3. Let's say it's gone up and it's got twice as big, and the center here is at 2 to 3. How do I undo that? You can use the word enlargement again, or some people use reduction if you don't. But enlargement is fine as long as your scale factor is correct. The scale factor to go back, if something's doubled, the scale factor going backwards is going to be 1/2. Yeah. Half the size. From double the size, half the size, going backwards. What's the center going to be? Well, for it to sit in the same spot, it's got to be the same center.
It's 2 marks, so if they get 1 wrong.
These are 2 to look for. Center and scale factor. Yeah.
Oh, they got it wrong? They got all 3.
Okay, so it's only 2 marks, so yeah. These are the 2 they want. Center, scale factor. Priyanka, you okay? Okay. Question 8 then. 125 to the power of negative 1/3. So, negative power, I can put 1 over, and that's the power of 1/3. That's gotten rid of the negative power. 1/3 then is the cube root. Cube root of 125. What's the cube root of 125? 5.
Yeah, I remember.
5, yeah.
But it says, if you said 0.2 is okay. Yeah.
0.2 is okay, yeah. Okay. Question 9. Y is inversely proportional to x cubed. So how do I write that? Y is equal x cubed with a k here. That's my start when I see inversely proportional, 1 over or k over. And I get 2 initial conditions. When x is 5, y is 2. So I put those in. When x is 5, y is 2. So 5 cubed. So 2 is equal to 125, k over 125. So I think k is going to be 250. K is equal to 250. So now I have, this is my formula, 250 over x cubed. Find y when x is 10. So when x is 10, it's 250 over 10 cubed, which is 250 over 1,000, which is 0.25. Okay, moving along. Nope. Moving forward. Okay, question 10. We have a right-angled triangle. Find the value of x. Okay, here's the angle that we have. Right-angled triangle, you're thinking sine, cos, tan. This is the opposite side over here. It's opposite the angle. This is the adjacent side. So I have opposite and adjacent. So that's tan. So the tan of the angle is equal to the opposite side over the adjacent side. This is a known angle. This is one of the ones from our table. If you remember that table, which you probably don't. If you're unsure, you cannot use a calculator in paper 2.
Sir, I have a question.
Yes, sir.
If for the working all this is wrong.
Okay. So if you're unsure how to do this, 1, 2, 3, 3, 2, 1, all over 2. All the numbers are square rooted on top. How do I get tan then? Tan is always sine divided by cos. So this is 1 divided by root 3. This one's just root 2 over root 2, which is just 1. And this is root 3 over 1, which is root 3. You can put it over 1 if you want.
Is root 2 over 2 the same as 1 over root 2?
Yes. Okay, so this is tan 60. That's what I'm getting at. This is tan 60. So root 3 is tan 60 is equal to x over 2 root 3. You're going to need to know this. This is definitely going to come up in paper 2. Definitely at some stage you're going to be asked about this table, something in this table. You're going to need to know it off by heart. It's not given as a formula at any stage. These are the known angles, yeah. I haven't finished yet, but yeah, that's wrong. Well, I don't know if it's wrong yet. I haven't finished it. So if I want to get rid of the 2 root 3, I multiply both sides by 2 root 3. This cancels here. So 2 times root 3 is equal to x. Root 3 times root 3 is 3. And 3 times 2 is 6. Hi.
Wait, if they only got the answer, that's what I want.
Yeah.
Instead of
Did you use a calculator? Use sine rule?
yeah, I'll do
Okay, yeah. You can use sine rule, yeah.
so it doesn't matter.
No, it doesn't say. It just says find the value of x.
But
As long as you didn't use a calculator,
if
yeah.
they did sine 60 times 2 root 3, is that 2 marks?
Like all I did was
I don't think that's.
Sine 60 times 2. So sine 60 is
I showed the word
root 3 over 2, so root 3 over.
but the black is theirs.
And they got the answer 6? Yeah, I think, yeah.
All three?
Yeah. Okay. Question 11. Simplify. Okay, so you need to be able to factorize. This is our first really algebra type question, or second algebra type question after the inequalities. Factorize. If I see 4 things, I factorize by factorize by grouping. So the common factor here is ax, and what's left behind is x plus 5. So that's these two, and then I do these two. Common factor is b, and I'm left behind with x plus 5, which is good. This is difference of 2 squares, x squared and 5 squared. So that's x plus 5, x minus 5. I need to be able to recognize that, difference of 2 squares. Rewrite the top line. Now this will cancel with this because it's all just multiplication. And my final answer is ax plus b all over x minus 5. Okay, next one. There's some inverses it. So f of x, this is a functions question, is this. I want to find the inverse, so I write it with x's and y's. I swap x's and y's, and then I try and find y equals. So I subtract 2 over this side, divide both sides by 11. So f inverse x is this, x minus 2 over 11. Next question is a composite functions question, g after f of 8. So we got to do f of 8 first. F with 8 in it is this one with 8 in it. So that's 11 times 8 plus 2, which gives 90. And that 90 needs to go into g of x. So g with 90 in it, I haven't even looked at g yet. G is sine x. Oh, so sine 90. So you need to know your table again. What's the sine of 90 degrees? 1. Sine is working up towards 1. Cosine is working down to 0. Last question. Okay, last question. Angle BAD. BAD, this angle up here, is the same as this angle here. That angle goes through all of these. It's a little bit confusing in the diagram, but that's the alternate angle theorem. So angle, what is it, BAD is 55 degrees because you're looking for only the words alternate segment. Something about alternate segment in there, and their reasoning gives the second mark.
How did you do this?
No, alternate segment. Because it's a segment of a circle, it's not a alternate angles, which is about parallel lines. Yeah. I need to check. I'll check the mark scheme and see what it says. It says alternate segment. You need alternate segment. Alternate segment. When it's in the circle like that, you need to say alternate segment. So just one mark. Angle BCD. BCD. Oh, I didn't work it out. 125, is it? 125 degrees. Because opposite angles, cyclic, quadrilateral. So you're looking for opposite angles, cyclic, quadrilateral for the reason in the second one. Yeah. Whoa. It's going to be really harsh and just give one there. Cyclic quadrilateral. Has to be a cyclic quadrilateral. No, that's enough. Not enough. Has to be cyclic quadrilateral. You got to say cyclic. It's got to be a quadrilateral in a circle, so it's only one mark for that. Okay, last question then, the logs question. 4 log. So you have to rearrange this. First thing, I'm going to use the log laws here. I'm going to multiply up by the 4 and up by the 3 to become a power. That's one of the log laws. Second log law is if I'm adding, I can multiply. So that's going to be x cubed times y4 is equal to 2. That's the second log law. That still equals 2 here. I forgot what I need to do. I need to get y equals. Okay. Now I need to get rid of the log. Yes, you can do log 10. I think that's the way I did with you guys. If I ever want to change a log into normal numbers, I think about this example. This is log 2, so this is log base 10 if I want to put in a 10, so it matches this. How do I get out of the log form? The base is 10, where 2 is. The power was 3 over here, so the power is this 2, and that equals this. Now all the logs have disappeared. Now 10 squared is 100. I still want to get y equals. So that's over x cubed if I divide by x cubed on both sides. That's y to the power of 4, not y. So to get what y equals, I need the 4th root on the other side. It should be plus or minus, but I think they give full marks if you didn't write in plus or minus for that. There's another way of doing it where you call this log 210 or log 1010. Okay, so what you need to do now is add up all the marks. It's out of 40 marks. Only out of 40. Now, not anymore. It's out of 75, so it's going to be double the length in future.
So nice.
But
It's not me who decides that.
Have to, like,